Welcome to today is April 24th, uh, 2017, and we're here in Seattle at the Perkins Coie Law Offices presenting RChain. My name is Ed Eichelt, and we have a group of RChain and a bunch of Ethereum enthusiasts as well. Um, I didn't know exactly what to expect in terms of audience. I have a deck that is a little bit of a pitch deck, a little bit technical, but I think it will give a good introduction to what RChain is at a high level, and also how we're set up organizationally, and also the motivation why RChain. You know, what's driving us. So I'll present probably about 20 minutes or so, and then Greg Meredith will talk about namespaces and other deeper, harder questions about RChain. Right, Greg? And whatever we want to talk about. We have this space, I believe, until 8:30, possibly later.
No one's coming in after you.
Okay. So yeah, we have as long as we need. And a few of us might be going out afterwards as well. We haven't quite set that. Feel free to gather afterwards as well. I think there's plenty of time for questions and so forth. So all of these team members are here. Greg, myself, Evan, and Navneet. We all said hello earlier. And Nash, yep. And actually, there's quite a number of others that aren't on the slide. Some like Mike Stay, for example, that's been working with Greg for 4 years plus.
Quite a bit longer, but
Forever. Somewhere between 4 years and forever. We've got a really great leadership team, and there's so much great talent in the blockchain space and Ethereum and else that we're going to ramp up pretty quickly in the next month or two, with a focus initially on the platform development, and then on the application side. So one of the things that's motivating us is, I like to start with the why. Why are we here? Well, the simple answer sometimes is, in Greg's case, I love the math. In my case, I love the tech, and I'm so cool about and all the innovation. But if we back up even a little bit higher level, the world faces so many global kinds of issues that governments are trying to solve them, corporations are trying to solve them, people are trying to solve them, but they're still in some cases getting worse. So we have an obligation to look for solutions, right, and contribute as we can. And so decentralization provides yet another set of tools that we can bring to bear for solving some of these global problems. At the heart of it, decentralization provides a set of coordination tools. And the coordination tools are about communication. Currency is a coordination tool. Governance, and the right to form organizations and around a cause. Those are all enabled in brand new ways by the blockchain space, and that's really exciting. One way to look at blockchains is that they provide a decentralized trust layer over the internet. So there's the base level protocols, TCP, IP, and so forth, web protocols, HTTP, DNS, and a bunch of them. But that trust layer, up to now, has been provided by governments, corporations, and banks, and they haven't always been completely trustworthy. They've been maximizing profits. They've been trying their darndest to be trustworthy. But it's difficult sometimes, right? And so one thing that a decentralized computer protocols provide is when the software is built correctly, there isn't much room to monkey around with a correct protocol. Where in the human systems, there's a lot of room to monkey around in systems. Now, this isn't a panacea either. There needs to be room for justice, mercy, the rule of law that software may not be aware of. So it's obviously a system that needs to be designed with care. But there's hope that this trust layer over the internet can be built, and that will be a worldwide compute utility that can be used for good. And so there's a lot of fundamental things that just weren't there prior to blockchain, with programmable assets or representations of assets, programmable trust, delegation of trust, ownership, money, identity, contracts, and then that provides all kinds of benefits to these kinds of world problems, but also in the context of just run-of-the-mill business problems. Two organizations that trade with each other, they need to reconcile, their accounts payable and accounts receivable and the trade finance between them. But also all kinds of other things that can be used in a decentralized way. Decentralized organizations popping up, governments popping up around causes. So obviously that's why blockchain has been so exciting to so many people. But there's the existing blockchains have a number of problems. I put them simply as they don't scale. On the right here, Vitalik Buterin, this was at DevCon last September in Shanghai, enumerated the problems as privacy, scalability, cost, and latency. And on the left is, the Sidechain solution to Bitcoin was presented at a conference. And so I boil this down to just a simple word we can get a hold of is scalability, but it's actually much more than that, and we'll go into those characteristics later. So kind of at the next level of detail, if we look at Bitcoin and Ethereum as the leading blockchains and compare RChain, which we hope will become the leading blockchain, what are the scalability promises that they're making? What's the promise we're making? 40,000 transactions a second or better. How can we achieve that kind of a throughput? Well, we'll go into that, but concurrency is a big part of that. Proof of stake is a big part of that. Subdividing the blockchain, which is sometimes that's been used in many industries, decentralized content delivery approach that's been used in previous projects, and it's really combining those in such a way that that makes sense as a whole. And so RChain is really a fundamental innovation, and not just RChain, but also the programming language and paradigm around RChain. And so that the innovation, has occurred. We've documented from a design perspective. We documented that in the architecture that I've pointed at, and that's on our website. And we're building the RChain platform. And the RChain Cooperative, is an organization that's responsible for that piece on the left. That'll be open source. We'll deliver a public compute utility that's available to everyone. It will use an economic token, but otherwise is free to do whatever anyone wants to do with, similar to Ethereum and Bitcoin. It can be forked if needed, and it's completely transparent in the operation. And then on the right is the RChain holding company and portfolio companies And we're going to leverage that platform and build decentralized applications on top of it in a way that makes sense together as a portfolio. And so we're going to help build a vibrant and profitable ecosystem on top of the RChain platform. Of course, others can do the same. We don't have a monopoly on building dApps on RChain, just like Consensus doesn't have the monopoly on building Ethereum apps. But at a rough level, we're similar to Consensus and Charter, that we're building out a set of apps that will become profitable and also help accelerate the RChain ecosystem. And we're doing that through working with subsidiaries as well as incubating projects to get going. A brief introduction to the architecture of RChain. This is kind of one level a little more granular than a layer cake model, if you will. In the dark blue is what will be running on an RChain node. And talking from the bottom up, we'll be running initially on the JVM. We'll be using Java libraries. We'll use peer-to-peer technology that's 0MQ initially, and MongoDB for the distributed hash table. That'll be accessed through foreign function interfaces. In orange is Scala, and in blue is Rolang. And so Rolang is the programming language that flows directly from the semantics of row calculus, and Greg can describe that in more detail. But it's the one of the calculi of concurrent processing. Okay, and we'll go into what that means and why did we go that route. And I'll let Greg field all those questions. So there'll be a number of components written in Rolang that will run inside this execution environment that will be Scala. And then there'll be interfaces on top of that and language bindings on top of which decentralized applications can be written. Now, the decentralized application, may have some logic in the what's close to the user, but the smart contracts that are running are on the blockchain itself. So you could think of there's a piece of that decentralized application that's ultimately stored in the distributed hash table and ultimately is running as a contract, just like the EVM does for Ethereum. I put this diagram together to help with some terminology we were having, struggling in the team to talk all the same way about things. So for those of you that are familiar with the Unified Modeling Language, this is a class diagram showing the data relationships. And I won't walk through this completely, but I want to just make a couple of points. One is that a node can operate essentially on multiple blockchains at the same time. So this is still all RChain, but there's different subsets that are subset along the lines of namespaces. So you could have a set of addresses and rules around that address called namespace A, and that operates, unless there's contracts that depend on each other, that operates independently of namespace B and all of its addresses and contracts. And so that's one of the mechanisms that allows RChain to scale. Is now, today in Bitcoin or Ethereum, if you have a transaction in China and a transaction in Seattle, those ultimately have to agree with each other on every node around the world that's running a full blockchain. That's not going to be the case with RChain. There'll have to be a critical mass of validators for a particular blockchain, but now those things can happen in parallel and ultimately concurrently. Also, for the same reason, essentially, the blockchains can be either public or private. And when I mean private here, I mean as private as helpful. This could be inside of a corporation, among a couple of corporations, or even down at the individual level, right? Let's say I have my own blockchain and I want to back up certain data on 5 machines that are nodes, and they're now synchronized. So we can we can introduce some very interesting use cases that couldn't be done before because of this kind of scalability from small and private blockchains all the way up to the scale of Bitcoin, Ethereum, and beyond. The way I characterize our value proposition is that the platform is enabling innovators to deliver a blockchain solution, a decentralized application that scales and that's trustworthy. And that goes readily to customers worldwide. So let's talk about the organizations a little bit. There's two primary organizations. There's the RChain Cooperative. Greg is the president of RChain Cooperative. It's set up as a cooperative so that it's ultimately owned by the people that use it, and the user base controls and influences the direction. So the cooperative has members. We haven't started our official membership drive yet, but will very soon. The membership can elect the board of directors. The board of directors can appoint officers. So that's kind of the way that decisions flow. And then members can also bring up initiatives, at least annually, if not more often than that, to make certain kind of guiding recommendations. So it'll take a bit of time before that comes into its full manifestation. But and then another key incentive is that certain traffic that is flowing through the platform will, essentially be collected through fees by the RChain Cooperative, and that's through the smart contracts, the protocol layers, and then that will be distributed to the cooperative members, called patronage dividends, just like when REI distributes its profits back to its membership. Except this may be a little bit more interesting. Okay, so that's the cooperative. And then there's RChain Holdings, which I described earlier as a for-profit entity that will incubate and have joint venture partnerships with existing blockchain companies and new ones to create a profitable and healthy ecosystem. So on the bottom left here, we've already, there's so much to explain on this chart. So RChain has a couple of cryptographic tokens, and one is really a temporary token that is actually not on RChain, but it's on Ethereum network as an ERC20 token, which is called the ROC. So ROC is a coupon, essentially what's the right phrase? I keep mixing this up. It's
the analogy was with Amazon's
promotional credit, yeah.
So basically, you're going to turn one of these ROC tokens. Basically, you're going to turn one of these ROC tokens into one of the protocol's tokens that lets you use the protocol when it exists.
Thank you. Yeah, and so then the protocol token or the economic token will be is currently called the REV, and the goal is to ultimately have multiple economic tokens, if that's feasible. Okay, so and we've already had a process called the redemption process, whereby investors and those that supported the platform for Scenario had purchased amps, were able to redeem the amps for ROCs, and so that's completed now. And then ROCs will later be converted for the ultimate economic token, currently called REV. Okay, so that's that bottom left. And then describe the membership. And then in the upper left are investors that will come into the RChain Holdings in more of a traditional way. These are private equity and others that will be buying preferred shares in the RChain Holdings stock. And I described the portfolio companies and customers. Cool. If we look at the history, this chart is like a year and a half or so old already, but I really like it because it gives an impression of how much is going on even a year and a half ago, and it's only exploded. You know, all the different kind of subs. I know you can't read it; it's kind of an eye chart, but there's infrastructure and base level protocols, middleware, and all these different kinds of applications. Well, all of those, most of those are applicable to RChain, and so we expect, as RChain is ready, that we're going to build out these kinds of solutions. At the base of this is essentially the RChain protocol and platform. Most of those apply, and then the RChain holding or completely independent companies and projects can build dApps and integrations on top of that. So I put sort of check boxes in most of this. There are some companies and some middleware that kind of go away. When you can have multiple platforms, multiple blockchains, and when you can integrate in the way we do and scale it the way we will, there's no need for some of these other solutions. As probably most in this room that are familiar with the price of cryptocurrency and so forth, we've seen a dramatic run up in Bitcoin, Ethereum, and many others, including Gnosis today. Maybe that's. But Ethereum is really the closest benchmark to what RChain is becoming, in that it's a Turing-complete programmable world computer. You know, the DAO hack was a pretty big crisis in Ethereum's roadmap, and it was a software bug, and it's because you know, Solidity and the intentions of the developer weren't obvious enough to the developer of what the kind of reentrant bug that it ultimately had, and so that led to a fix and a rollback of that particular contract. And then, of course, with the announcement of the Enterprise Ethereum Alliance, and because of threats on Bitcoin and potential fork of Bitcoin that are happening right now, there's a lot of interest in Ethereum. So we expect great things to happen with RChain, and those are just market signals of what might happen. So in terms of how we'll go about building RChain, we're obviously building the platform first, but we'll do some of this in parallel as we go. I kind of look at this as sort of three major chunks that the holding company or again, you know, incubated projects or partners that we form. We have, just like in Bitcoin and Ethereum, we have some basics we have to cover around wallets, around identity solutions, not just the self-sovereign kind of identity, but also KYC kinds of identity that's really critical for banks and finance institutions and so forth. Privacy, secure messaging, and generic tokens, kind of a corollary to the ERC-20. And then we'll have foundational businesses, social networks, token exchanges, and several others. And then differentiated offerings over time. The social network will add an attention economy, and what's really interesting here is some of these things become quite practical when you have a blockchain platform that will scale, and they're hard to imagine prior to that. So attention economy is one good example of that, where every post could become a smart contract, and that's our intention. So now the post itself carries value and can carry sort of a chain of provenance back to where did this post come from? Who was the creator? And how should they be rewarded once this post is viewed or once it's promoted and so forth? So this becomes very interesting. We'll also build marketplaces and all kinds of other applications over time.
how many people here use Facebook? Just raise your hand if you're a Facebook. Okay, great. So about half the people here use Facebook. So you can picture, or if you use Twitter, you can picture. Just think about your Facebook feed, right? And now think about the 500 million people who all have Facebook feeds. And every single one of those posts has the potential to be a smart contract. And now think about how that might run on the Ethereum network at 15 transactions per second. Not going to happen, right? So something radical, some radical shift has to take place if you're going to run the kind of application that Ed just sort of tossed off. Oh yeah, we're going to do that too, right? So that's really, you know, it should land somewhere where you're going, what? Really? Right. So let that be percolating in the back of your mind as you listen to the rest of this.
Thank you, Craig. So we've worked out the rough sequence. Actually, it's not that rough, but pretty detailed sequence in which the milestones need to occur on the RChain platform. I'll make these slides available, and we'll post them on the RChain co-ops Slack. And we also have a sequence of DApps that we're intending. And we're going to work on aligning those two schedules. So with sort of the end-to-end kind of behavior that the applications need, we're going to align those schedules and lock in a schedule, an agreement, and then execute accordingly. And Greg can talk more in detail about the platform and so forth as we go on. So that was kind of at the base layer in dark blue. Above that are these classes of applications that I was describing before, what I was saying about basic dApps, social dApps, marketplace dApps, and others. And we have a much more detailed roadmap for these. I don't have the timelines on these yet. I'm pretty cautious about promising timelines until we have the not just the funding, but also the sort of disciplined planning discussions to say, okay, how many people do we need and what places? What's the rough size, not just of this high-level thing, but let's subdivide it and so forth. So I'm not giving too many dates, especially publicly. We obviously have to have these conversations when we attract people, when we attract investment. You know, we have customer acquisition plans in the works, for example, on a social network. And I just, without talking in too much detail, this is also very hard. You know, as hard as the tech is, so is customer acquisition, and so is customer retention. You know, it makes or breaks projects and companies. We talked earlier about sort of how smart contracts can be used not just in a very occasional way, but actually as the platform scales in a very high bandwidth way. And they'll, the smart contracts are essentially the collection mechanism for fees and commissions. And so as long as they're providing value, whether that's in the native economic token or in an application-specific token, they'll be readily used. And especially as the suite of application becomes interdependent on each other. So you have contract A depends on contract B, depends on contract C. That should provide very reliable, but also stickier and stickier kinds of structures, so that will be defensible from a profitability perspective. So that's all I had to present. Happy to take a few questions, especially those that are kind of more organizational or directional kinds of things. I'm good at addressing those. And then Greg will get up and talk more on the technical side of things. So reactions and questions? Chris, yeah.
So is there like some kind of inherent, can you guys hear me or just this?
Yeah, turn it on.
Okay. So So is there some kind of inherent like ethic or philosophy that you kind of imbue the cooperative with? Because I mean, cooperative kind of is evocative. Like you mentioned REI, and they have some kind of corporate responsibility, like kind of sub thread.
Yeah, yeah, we have a commitment to to global issues, but also that the network is ultimately owned by the people that use it. And Greg, feel free to elaborate more, but that's the essence.
And what gives me a lot of hope, the first time I really got a taste of it was in the Ethereum community, where I really felt like a lot of the community was young, and a lot of the community was not sitting around complaining. They were rolling up their sleeves and getting something done. And the thing they were getting done was gigantic, right? Basically redoing the financial infrastructure and the global compute infrastructure. And why? Why would we want to do that? Well, we want to do that, as Ed said at the very beginning, because the problems that we're facing, especially when it comes to climate change, are enormous. In the next 40 years, the amount of change that the human race is going to have to deal with is enormous. And the coordination technologies that we're currently using, so the existing currency mechanisms, which are inextricably linked with governance, right? They're not moving at a pace that is going to match the rate of change that we're going to have to deal with. And what I saw within the Ethereum community and the rest of the blockchain space is this response of, well, who else is going to fix it if we don't? And RChain is right in alignment with that. Who else is going to fix it if we don't? Yeah. So that's kind of the ethos. Yeah.
Do you want to just take this second half?
Yeah.
So I think you're absolutely spot on in asking about what's the sort of culture and ethos of the cooperative, and it's absolutely a cooperative, both officially and in terms of its intention. And I think that makes a lot of sense for a blockchain application to be a cooperative, because blockchain is inherently sort of dissimilar from a centralized, like Facebook, for example, basically owns and operates its machines and its service. And a blockchain is intrinsically not like that, where it's a bunch of people around the world getting together and agreeing on the protocol that they're going to use and operating it together. And I think it makes a lot of sense to apply cooperative structure to the organization of an entity that is, it fundamentally works in a cooperative fashion.
So, I mean, I guess one characteristic of that cooperative is that you would have a more distributed ownership. So I guess there's a couple follow-ons. So like today's Gnosis sale, like almost half of the coins went to like 2 separate transactions. So something like that kind of distribution would be counterproductive in terms of like the cooperative ethos, in my opinion. And then kind of the second question is that there's some, I was just reading about some kind of redemption of like AMP into the Rev, I don't know if it's Rev or the rocks. So what is the current distribution of those, like, you know, unique like wallets versus market cap or outstanding Rev?
So I can't speak to the numbers on that. I'm sure there's somebody who can bring that up. But I think the point to make is that this is about a compute utility and not a market investment. The token is not intended to be an investment in any way, shape, or form. It is supposed to be something that you can use to give an instruction to the blockchain, please do this for me. It is a compute utility, and this is how you tell it to do something. So people who are looking at this like, I want to know how much of the percentage stake of the total that I own, it doesn't matter. I mean, it's very much like if you're subscribing to a compute utility, maybe you're, you know, subscribing to a slice of a data center, it doesn't matter to you that other people also have a share of that data center. Doesn't make any difference to you.
Maybe in terms of governance.
there's definitely decisions that have to be made collectively, but you're not
Oh,
losing.
so
value.
regarding the co-op, what feedback have you received from, your customer base, in terms of like a lean startup approach? I mean, have you had customers saying to you, yes, we would like to be on the co-op, and do they initiate that, or do you introduce that to them? And if that's the case, also, what is the entry point in terms of cost, the entry cost for something like that?
So the co-op really is intended initially to be more of a individual membership. We really haven't. I've got.
Yeah, but that doesn't go into the Mac. That end doesn't go in.
You sure?
I'll try it again.
I've got another one. So sorry about that. Yeah, initially the membership we're thinking more as an individual thing because it's just one member, one vote. So a corporate membership isn't going to have more influence than an individual person. Although it's possible that corporation that's generating a lot of transactions may benefit if we don't cap the patronage dividends that go back out to members based on the amount of traffic they actually use. So I'm not sure I completely answered your question about what we're doing to attract members.
Yes, so in terms of, hey, we have a great idea, we want to create a co-op, and it's a fine business model.
Yeah.
Did customers come to you with this, or did you feel like, no, this is the way to go? Did you bounce this idea with them? And going back to what I'm trying to do with patient identification, where I would see that is hospitals, providers, payers, they would be part of such a co-op. You first have to, though, sway them to becoming part of the co-op and the initial cost for doing so. So I'm just curious to know what you ran into, and or what made you feel like, yeah, if we did a co-op, build it and they will come.
Hard sell to people. You're like, we're gonna do open source, so we're not gonna like sell software to people, and we're gonna do this cooperative instead of this for-profit corporation. Okay. So Greg was the one pushing for that, even though people were against it.
Yeah, it's true. It's true. I mean, I actually have a lot of experience in cooperatives. Before I went off to Oberlin College, I lived in Morgantown, West Virginia, which had a very large cooperative community. But then Oberlin College, 25% of the student body lives and works inside cooperatives. Right? Oberlin's motto is learning and labor. The co-op I was in, participated in, Harkness Co-op, we made all our own bread, all our own tofu, all our own yogurt, granola, et cetera. And we managed and ran the whole dormitory and everything. And so that was kind of my experience. And one of the most wonderful things about Harkness Co-op, and I think many of the other co-ops, was on the first night we decided how to decide. And that's essentially what we've been doing within the RChain community is beginning to bootstrap the governance model. And it's a tricky process, right? Because if it's too loose, and I realize that I'm kind of wandering away from your topic a little bit, but if it's too loose, then it's too easy to sway and move in one direction or another and keep tacking and never make any progress. On the other hand, if it's too rigid, then you can get stuck in energy wells, so to speak, in the sort of energetic landscape. However, now that people have begun to get a taste of what's possible, and they look at models like REI, they realize, oh, there's a really positive economic engine. So think about it, right? So a large group of physicians decide they want to run a lot of their smart contracts, so contracts that handle patient information, for example. And so they run it on the RChain infrastructure. Because they're members, they get certain deals on how much rev it costs them to run those contracts on the RChain. And then at the end of the year, they get big rebates as a result, right? But what's the form of those discounts and rebates? Well, more economic tokens to run stuff, right? So it's this virtuous cycle. And once people begin to go, that starts, then the penny drops, so to speak. Does that make sense? Yeah, cool. Sure. So do people, I was just about to ask if people want a 5-minute break before we get started. Okay, the mic is on. All right, let me just also just hit the QuickTime record button. And okay, good. And back to okay. So last time I was here, I sort of gave a high-level view of the mathematical underpinnings and some of the architectural considerations that went into the design of RChain. Now, probably a lot. I don't recognize actually a lot of faces here, so I can dive back into that material. But I really wanted to. That was kind of a broad view, and I really wanted to focus in today on just one idea. So if you walk away from this talk with only one idea, that's cool because there's basically only one idea here. And this idea we've been calling namespaces, and it goes back to well, I mean the problem of naming is a 3,000-year-old problem or better, right? But in this particular case, the way I've conceptualized the notion of names goes back to a paper that I wrote in 2005 with a colleague of mine, Matthias Radestock. And it goes right to the heart. I was very inspired by the computer scientist and mathematician Robin Milner. And he has a very beautiful model of computation, but there was a bug in it. There was a flaw. And nobody noticed the bug or the flaw except me. And it bothered me a lot. And I wanted to recover Robin's breathtakingly beautiful work, for which he won the Turing Award. And so I found a way to do that. And the idea actually came to me in 2002, and I didn't write it down until 2005. And then that became a pair of papers, which you can look up now. One is called the reflective higher order calculus, the row calculus, which is at the heart of Rolang and the RChain architecture. But then the other one is called namespace logic. And so here I'm going to just talk to you about namespaces and why they make RChain special. So that's kind of the idea. And I want to start by doing some mind expansion. A friend of mine, Michael Benedict, who's pictured here on the left, he's at least he was the chair of the architecture department at UT. I got to know him because he would come out to the MCC, which was the first industrial consortial research project program in the United States. So he would come out and bend our minds about actual physical architecture, and we would bend his minds about computational architecture. And one of the things he said to me, which was totally obvious at the moment he said it, but I'd never thought about it until he said it, he said, one of the functions of architecture is to provide addresses. Right? We're sitting here in a room, and this room has a location in a building, this building has a location on a street, that street has a location in a city, the city, and so on, right? And so this addressing function of the physical architecture, the built architecture, it locates people and things. Okay? And because of that, it enables message passing. Right? I can write a letter. And so in this picture I've got Michael Benedict writing a letter to Jaron Lanier, who is another person who's thought deeply about these kinds of things. And through these message passing protocols, we do complex coordinations, right? Which is what Ed was talking about, right? Currency and other kinds of things are coordination technologies. And we have to, so RChain is all about thinking deeply about what goes into a coordination technology, what's necessary to do that. And addressing is part of that. And it turns out, of course, that it's not just the architecture of the physical environment, of the built environment, that supplies addressing. The architecture of the digital environment also supplies addressing. So I've given 3 examples up there, and you can use them to contact me if you want. So one is, of course, phone numbers. The other is HTTP is URLs and URIs are a way of locating resources and finding resources. Email addresses, likewise. So the notion of addressing is fundamental to coordinating. But I want to kind of, again, keep expanding our minds a little bit and suggest that the notion of addressing is actually it's a part of the architecture of physics itself. So general relativity is one of my pet hobby horses. I love to think about Einstein's field equations, and partly because those inspired the structure of the row calculus. But what the general relativity struggles with the concept of addresses. So essentially, at the heart of general relativity, you have some manifold, whether it's a donut or some closed surface, right? You lay over top of that closed surface a bunch of charts. And what are those charts? Those are the space-time coordinates, right? So it's like, a grid work which allows you to locate events in the physical world with measuring sticks, yardsticks, and watches. Okay? And I just want to mention that there's something that Einstein gets very right. So Einstein's conception of the relationship between addressing and the way matter and energy stretch time and space is important. Right? That idea is important because it talks about the mutual recursive relationship between coordinating processes and addressing. So in Einstein's field equations, what happens is there's a thing called the metric tensor, which is giving you these charts that lay out over the manifold. It's a grid work, right? And on this grid work, you can locate things. So the metric tensor gives you these charts, and then the stress energy tensor tells you where all of matter and energy is distributed. So it tells you about the distribution of resources with respect to this grid work. Now, the funny thing is, the weird thing is, that when you sprinkle matter and energy all over this kind of grid work, it stretches the grid. It shifts and bends the actual fabric of space, which then changes where the lines intersect, right? Which changes the distance between the dots, between the places in the grid where lines come together. So matter and energy stretches space-time, and then space-time itself starts to put matter and energy into motion. Because it's all stretched, like marbles in the picture here, like marbles on a rubber sheet, they start to move and roll, right? Because of this stretching of space-time. So think about it. There's a loop. There's a cycle here. You change the distance between things, right? Which then causes them to move, which then causes the distance between things to change, which causes them to move. So this recursive relationship is very right. And if you look at the row calculus, in fact, if you look at Robin Milner's original pi calculus, it has this property. It was one of the first models of computation to have this property as a notion of dynamics that wasn't couched in Newtonian calculus. Okay, now there's another thing that it gets wrong. So what Einstein's field equations get wrong is that it's not even a testable scientific theory. And you should be going, what? What are you talking about? and all tests of the Einstein field equations are tests of approximations. Maybe you didn't know that. They're tests of approximations. And what's really interesting is that the theory as stated, the Einstein field equations themselves, require universe-scale knowledge of the distribution of matter and energy. Now think about that for a minute. You see that little dot there on the fringe of the Milky Way? That's us. And we're a really tiny portion of that dot. And yet, to have this theory work out, us little tiny portions of that dot have to have a universe scale size understanding of the distribution of matter and energy. It's not realistic. That's not how we work. We work up by building up little local views, right? We can see this room. We can reason about and experience this room, right? And then if we get on our cell phones, we can call someone else in another room. Tell us about your room, right? So we have to piece together our understanding of the universe, our understanding of addressing and its relationship to coordinating processes in a way that you start with a whole system, and then the whole systems cohere into larger whole systems. Hopefully that's making sense. And I just want to say that this is very much like the blockchain, right? So if you think about the Bitcoin blockchain, how many people use Bitcoin? Okay, awesome. So when I talk about addresses, you know what I'm talking about, right? So you can think of the Bitcoin blockchain as just providing a big grid work. And what do you locate at those at the addresses, the points in the grid? Well, you locate Bitcoin. That's what you locate. And then the processes that are coordinating through this grid work are agents like ourselves, as well as financial programs, right? So that's the kind of analogy, right? And I want you to sort of understand that the scope and the scale of the problem of addressing, right? It goes from the physical architecture all the way out to the digital architecture with physics in between, holding it all up. It's the same idea of how processes coordinate through a notion of addressing. So I also want to say that if someone like Einstein, who thought deeply about this, got it wrong, then it's quite possible for someone like Vitalik or Satoshi to get it wrong the first time around. It actually requires a little bit more thinking to understand, and the shift in thinking is fundamental. The shift in thinking is towards decentralization, right? The mistake in Einstein's thinking is, I have a place to stand where I can see the whole of the universe. And we don't have that. Instead, we have lots of little decentralized views, and each of those views are whole in themselves, and then they come together into a larger whole, and those wholes come together into a larger whole. Is that making sense? Are people following me? Sweet. Okay. So RChain proposes that the blockchain is not a universe, but in fact a multiverse. And then, in fact, we don't want to have universe-scale visibility into the distribution of resources, right? If we have an interface between RChain and the enterprise, for example, a hospital, or a set of insurance companies, or a collective of physicians, we don't necessarily want to look into their own particular distribution of resources. What we want them to do is to be able to talk to us, to the blockchain in a particular way that makes sense, right? You want to have this coordinated means by which you can glue together these wholes. And each universe is a space of addresses into which we do have a view of the distribution of resources. Okay, so and we call this space of addresses a namespace. Is this beginning to make sense? Is this beginning to connect for people? So imagine that you've got, the addresses for the Bitcoin blockchain, that's one namespace. The addresses for the Ethereum blockchain, that's another namespace. And other kinds of namespaces. So what might be some of the others? Oh, I have to make a bow to pop culture here. I was talking with some of our marketing team, and they were asking, well, what do we call these namespaces? Namespaces are too foreign and too technical, right? And so I said, well, I was just finished watching the Firefly series with my kids. I was introducing them, and I said, well, why don't we call them verses? In the sense that each one of them is a little universe of its own. And what we want to do is we want to think about bringing all these verses together under a multiverse. But a little bit more seriously, inside each of these universes, you have different guarantees about the resolution of addresses to resources. Okay? And lest you think this is a crazy idea or too space age, okay? That's exactly the proposal in the URI and URL specifications for HTTP. This is exactly the idea. So the scheme at the top of HTTP is a promise for how these paths after HTTP resolve to resources. And the mail to at the top of the URI mail to is a promise about how this email address resolves to a particular resource, in this case an SMTP email inbox, right? Is this connecting? People understanding? Cool. All right, now RChain is different from HTTP because it specifies a relationship between the agents that use the names and the namespace itself. Okay, so in particular, if I guess a lot of people in here haven't been exposed to Rolang. I was hoping there might be more repeat customers, but Rolang is, and I'll just pull up some slides from the previous talk, and we can go through those. But Rolang is the contracting language built on top or derived from the Rho calculus that offers a codification of the contractual relationship between agents that are utilizing the namespace. And the other thing that's important here is that it provides a set of built-in namespaces or system-level namespaces where decentralized consensus is maintained, right? So if you operate within some of the standard namespaces that are provided by RChain, then you will get guarantees about global visibility for those people that are participating in the namespace. Are people tracking what I'm saying? Yeah? Feel free to interact. Feel free to engage, right? If you're not tracking, raise your hand. Say, I'm not quite getting it. Okay?
Well, I think of them maybe as variable naming, that it's pointing to a data resource.
That's a great analogy. And in fact, that you just read off my next slide. Very, very good. So let's look at this in even yet another layer of detail. So namespaces provide, for example, both performance and security abstractions. So you could imagine that these names are not just addresses on a distributed ledger, but they're names that map onto locations in memory inside a single virtual machine, right? And you could say, you could even say that the names that are being utilized there only ever hold either other names or arithmetic values, right? So that's one example. So then you can use names to refer to locations in the stack and the heap of a virtual machine, right? And that's a little sandbox of resource accesses and a particular kind of promise. For example, the JVM offers a particular kind of promise about variable access, right? And by extension then, the Scala language offers a similar kind of promise that way. Likewise, a namespace can be mapped onto access to system-level resources. So what are some examples of system-level resources? Well, file storage, database storage, network access. These are all, and any other OS-mediated resource. Does that make sense? Right? So what this is saying for those people who are, object capabilities people, this is saying that namespaces and the model of Rolang contracts are, it's a natural object capability language, right? So hope for some people that may resonate. I think Nash is nodding his head, but so that's kind of the idea. And how does this get realized onto physical? Well, Ed's kind of walked through this before. Let me map it down a little bit. So you have user level contracts, and user level contracts involve what we think of as agents or processes that communicate by message passing over these names. So if you go back to the picture that we had before, I have an address, contract Michael Benedict has an address and wants to send a message to Jaron Lanier. How do they achieve that? Well, they post the message at a particular name or at a particular address, and then it shows up on the other side of that name. So you can think of the name as like a tube with two ends, right? So contract Michael Benedict shoves something in the tube on one end, Jaron Lanier picks it up off the other. Now, how that works in a distributed setting, because copies of the Michael Benedict agent are running on many nodes, and copies of the Jaron Lanier agent are running on many different same computer, similar nodes on different computers, right? And so you have to worry about, well, if this copy does one thing, but this other copy does a different thing, right? So imagine, for example, that not just Michael Benedict, but Le Corbusier, Henri Le Corbusier, is also sending information to Jaron Lanier, right? Then it could be that Jaron Lanier gets mixed up about which message Jaron Lanier picks up, right? Because they're both sending to the same address. And so you have to ensure that you have a similar kind of execution on all of the nodes. And what is guaranteeing that is the same kind of thing that's guaranteeing a distributed view of the Bitcoin ledger, right? So there's a consensus algorithm, which is making sure that all of the transactions proceed in the same fashion on each and every node. Again, is this making sense? Do we have a mental model? So that consensus algorithm is expressed in terms of what we call the Casper contracts in this diagram here, right? So you can think of each one of these silos here as nodes that are effectively a node in the RChain network, and they're going to be connected via some kind of distributed communications mechanism that we associate with the internet. So, for example, an AMQP protocol, or another example would be 0MQ, which is not necessarily AMQP compliant. Now, the Casper contracts run against a VM that is the semantics of which is directly derived from the row calculus, which I mentioned at the beginning. So the row calculus provides a fundamental model of computation that fits with this domain, and we'll talk through why that's the case, since this is a fresh audience. But just at a high level, the row VM lines up with this domain, and then that is compiled down to an existing VM. So this is a VM that's built for concurrency. Now this is very important because if you think about it, just picture in your mind for a second. I have pictures of this in the previous talk, but picture in your mind I-5, right? So if there's not a lot of lane crossing, there's a lot of cars that can flow through on each of the different lanes on I-5. If you have a lot of lane crossing, or if they have to narrow down to a single lane, you get a lot of synchronization, and because you get a lot of synchronization, the throughput on I-5 slows down, right? So this is exactly the situation that we have with the Bitcoin network or with the Ethereum network. What they require is a global schedule across all the cars, right? All the cars that are flowing down the highway have to be synchronized. But that's too much synchronization. It's too much of a requirement when, in fact, if you think about it, each of those cars is like a little transaction. Does that make sense? And most of those cars don't have to engage with each other. Just like when you went and got a Coke or a coffee or a tea, that transaction was independent of someone on the other side of the planet buying eggs, right? And that's why the financial network scales, right? So it's the same idea. If you have lots of lanes and little synchronization, you can get lots of throughput. So that's why the concurrency is so important. And that's why we need virtual machines like the Rosette VM, which we just happen to have in our back pocket. The Rosette VM provides a kind of a concurrency model that is very natural. And then connected, what makes the Rosette VM scale up to internet scale is that we provide a level, we basically are providing a kind of, how do I say this? It's a transducer. It's a layer of connection between the Rho VM and its semantics and the Rosette VM and its semantics, which we call a tuple space. And that's essentially what Ed was referring to when he was talking about the distributed hash table. And then that's layered via this notion of namespaces over top of storage, networks, communications, and these kinds of things. So one of the things I wanted to give people a sense of is where we are when it comes to the development of RChain. So one of the most important things to come out of Ethereum was the specification of the EVM, the Ethereum virtual machine, right? And let's think about that virtual machine for a little bit. First of all, as I just pointed out, concurrency is very important. The EVM is decidedly sequential. This is why they are suffering 15 transactions per second. The other thing that's really important is the EVM was invented essentially by one person who wrote a spec, and then it's been exercised for the last 2 years in virtually no production capacity. Right? So let's think about that. We would like to rewrite the global financial infrastructure on top of a virtual machine that is 2 years old, invented by one guy, and that is sequential and doesn't match the domain requirements of concurrency. Now, again, not knocking Ethereum. I am so grateful that they charged ahead and forged ahead with the idea of putting a computer on the blockchain, or the state of a virtual machine on the blockchain, instead of just a ledger. This is a brilliant idea. Now, they didn't know about the other possibilities in terms of concurrent virtual machines, because that's new technology. I mean, it's not exactly new because we've been thinking about it for 35 years, but computing, like other branches of science, proceeds slowly. And so that information hadn't yet gotten out to the cryptocurrency community. Now, in addition to those considerations about the EVM, what we want to do is to ask about the correctness, right? We want to ask about its semantics. And this is super, super important if you're concerned with issues of security. So in particular, if there needs to be a relationship between the contract language above and the execution of the virtual machine below. And one of the things that Ed pointed to was the DAO bug, which was effectively a disconnect in the programmer's mind about that relationship. But it can be much, much worse. In particular, you could do bytecode injection. So if you don't know how the semantics of your contract at the user level is supposed to be related to the semantics of your virtual machine, then someone could say, oh yeah, well these bytecodes are just as good as those bytecodes. And then you run those bytecodes, and they kind of do what you wanted, but they also go and gobble up resources on your machine, or delete files, or do any kind of other malicious thing, right? So we've now looked at 4 different properties. The Rosette VM is distinct from those because it does have a built-in model of concurrency. It does have a clean, clear semantics and a clear relationship between the semantics above, which is the Rho VM, and the Rosette VM. And in addition, it's been deployed in an industrial setting. So data provisioning for Ameritech and data cleaning for Belcore. Personally, I built an ATM network management system on top of it for Sumitomo and TSB. So those are just a few of the commercial deployments against which the Rosette VM has been deployed. So it's a different animal. The technology is much more robust. It's much more mature, much more developed, and it's designed for this particular domain. So I'm gonna stop there and start to get some feedback while I bring up the next set of slides. So comments, questions, thoughts?
Take a stab.
Yes.
Are we coming back to namespaces?
Yes, we are.
Okay.
Yeah.
I can save it then.
No, go ahead.
Okay.
Yeah.
It seems pretty obvious how you would use namespaces to do sequestration for something like that, right?
Yeah.
It's not clear to me what you mean when you say one namespace could represent Bitcoin addresses, right? Beyond you've sequestered Bitcoin addresses in this way. Because it sounds like either you need to replicate Bitcoin's network
Right.
in the VM,
Right.
for instance,
Well,
contract and
or you proxy.
proxy was,
Yeah, proxy is the most obvious answer. Of course, that has all kinds of security issues, but that's another approach. You proxy.
And do you imagine these proxies or translation layers or forwarders or adapters or whatever you want to call them being developed for many different blockchains? Is that
Yes, absolutely. And in fact, one of the things that we really like about the RChain architecture is that it's kind of robust against forking, because a fork of RChain is just another namespace. Two RChains talk to each other, right? So that they don't necessarily. As long as you maintain an understanding of the distinction of the namespace, they can't even disagree on the distribution of resources because the names are distinct. Right? Does that make sense? Yeah. Navneet, did you have a question?
So, if, the forking point you're talking about, so if you have to relate, past transactions or history of transactions, how is going to accomplish?
I was just.
So, yeah, my question is, there are, two different namespaces, and then, you fork the code, and now you have a new namespace.
Mm-hmm.
So, if you need a history of transactions for a particular address or a particular, organization, then you may need to write some sort of contract or something like that.
Yeah, right. So again, that has to do with the application view of what it means to fork, right? So you know how when you create a new channel in Slack, one of the questions it asks you when you create that channel is, when new members come in, do they see a history of the messages, right? So that's an application semantic level question, right? So you're providing a guarantee about a notion of history, right? So one guarantee of the notion of history is they're not related. So the genesis for that is the moment of the fork, right? Another notion of history that can have utility is this was a fork, and so this transaction is related to that one because it was present at the time of the fork. Does that make sense? Sweet. Okay, so let me just quickly check in and show you why. So we talked about the notion of namespaces, but a namespace is related to the agency of or the model of computation on the namespace. So remember when I talked at the very beginning that there needs to be a recursive relationship between the processes that are coordinating and the names that they're using to coordinate, right? So this is like the grid that you lay over space-time, the sort of clocks and yardsticks, the grid of clocks and yardsticks that you lay over space-time, and then the processes of matter and energy that interact through that grid, right? So it turns out that there's a recursive relationship between the two, and if you get that recursive relationship right, then you have all kinds of properties that you don't otherwise have. So let's just look at some of the features that make the row calculus fit for the blockchain. So we just have a brief checklist here, and then we can go backwards. So Ed mentioned that the row calculus is Turing complete, right? So we have a notion of completeness. Now the notion of the holes fitting together into larger holes. This is this notion of compositionality. So you don't just need that the namespaces fit together. You also need that the agents that use the namespaces fit together. So think about it as like the community that's using the Bitcoin blockchain, right? That's one community. That's one set of agents that are coordinating with each other. That has to be, so when you circumscribe that community within a particular namespace, then you have to be able to fit that community together with other communities, right? So this is the notion of compositionality. Likewise, we've talked a lot about the notion of concurrency. One of the things we haven't talked about is the notion of complexity. Can you measure within the model of computation, can you measure the resources that are being utilized as a part of the computation? Now, if we hearken back to the Ethereum virtual machine, this was one of their claims to fame, right? Why it was important to have this special purpose virtual machine was they needed to be able to count the number of steps in the computation, and they needed to be able to count the amount of storage that was utilized by the computation. If you start with a model that already has that built in, you don't have to have any special purpose virtual machine for this. Okay? So those are kind of the four top C's: completeness, compositionality, concurrency, and complexity. The other thing that's really important when we talk about the DAO bug is being able to apply as a part of regular development methodology. We need to be able to apply methods that will guarantee correctness. And some of the methods that we apply within the Roland contracting language is a form of type theory, or the ability to. How many people here program? Awesome. Okay, so then you're familiar with languages that have types. So Java is an example of a language that has types. Now it turns out that in the last 30 years, we've been refining and advancing the notion of type so that you can say a lot more with types. And one of the things that you can check with types is the kind of behavior that you see over contracts. Do all parties agree on the use of this resource? A really good example is the DAO bug. Do all parties agree that there can be no race to acquire this, to re-enter the contract? And so one of the things that we did with the Roland contract, when the DAO bug came out, we rewrote a portion of the DAO contract, the one that was buggy, inside Roland. And what did we discover? Well, it was exactly this kind of race to the reentrancy. And if we just introduced a type for the contract, then what happened? The compiler for Roland caught the bug. Okay, so having type theory is not just a nicety. It's not just about reusability. It's also about making these things robust enough to scale at global financial scale. When you have $300 million flowing through your contracts, it's important that you have this kind of methodology baked in. And then finally, programmers don't write programs. Programs write programs. And programmers utilize those programs to crank out programs, right? It's a mind-bending thing, but that's exactly what you do as a programmer. You're using a text editor, which is a program, to write your programs. You're using programs to automatically generate your programs, right? Meta-level programming is absolutely at the heart of scalable software development. So you have to have, if you want to do robust, scalable development, which it's not just this, it's scale, as Ed, I think, tried to indicate quite nicely, scale is not just about how fast your thing runs. Scale is also about how robust your code is against errors. Scale is also about how rapidly you can create robust code, right? So, I mean, one of the things that was very clear in industry was people took a language like C++. It was speedy by comparison to Lisp of the time, right? But the development process slowed to a crawl. People couldn't get code out the door fast enough. And that was one of the major reasons for the adoption of Java, because Java was just kind of halfway between C++ and Lisp. And so people could realize the kind of productivity gains that enabled them to get code out the door at a rate that was roughly keeping up with the market, right? And at the heart of that is this ability to do meta-level programming, to use programs to write programs, to scale, to use computers to scale your efforts. So if we look at these, if we look at all of these characteristics of the model of computation, of the agents that are the contracts that are executing against the namespace, there is exactly one model of computation that has everything, and that's the row calculus. And that's at the heart of the virtual machine. So I'm not going to go through all of this, but let me stop and make sure that people are tracking there. Is this making sense? Is this making sense? I feel like a lot of people are nodding their heads, but they're not quite there. Right. So the takeaway is you need to have two things that fit together. One is a notion of namespace or a notion of addressing that allows for chunks of addresses to be held together within a particular container. Now, and then you need to be able to glue those together, and then whatever you've glued together, you need to be able to glue those together in a higher level container. So, yes? So I just want to confirm, so even though these are isolated or they're concurrent, they're separate from a single global view, you can still trust that if someone is running a contract that maybe you can't see into, but you can still trust that it was run as needed? Again, if you have running a contract, if you're running a contract, then you're going to have some access into the namespace of that contract, right? So your visibility will be at least into the namespace of that contract. If that contract touches upon other contracts that have a namespace that impinges upon that, right? So there's an interface between the two namespaces. You'll have visibility at least as far as the names that they impinge, in the intersection of those two contracts. And for that scope of visibility, yes, you have absolute trust. And beyond that scope of visibility, you don't care. Right? That's the important point. You only need to trust at this name, I saw this value.
So whatever dependency you have, however they got to that result, you don't know, but how you're going to react to the result, you do.
Exactly. So again, if we go back to the physics model, you have a light cone. Inside the light cone, you understand causality. You know that this event comes before that event. Outside of that light cone, you can't say anything about causality. You don't know if A comes before B. and it doesn't matter. It doesn't impinge upon you. There's no experiment that you can run which will enable you to make that matter to computations that are relevant to you. So it's the same kind of idea, and it's an idea that goes back to the industry for a long time, right?
Yeah, because this is how it actually works. This isn't even just to be clear, this happens on your PC right now. Like on the Intel chip, you have indeterminate times for the cores. Right? So there isn't a computer manufactured anymore that has the thing that you think you want.
Yeah, that's exactly right. No, no,
I
no.
wasn't advocating for it. I just
No. I know. But I mean, I love this kind of spirited dialogue and spirited engagement, right? So you need to be able to glue the namespaces together, and likewise, you need to be able to glue the agents that are using the namespaces together, right? And that's where this idea of verse comes around. Now, there's one other subtle idea that I want to get across, and then I'll close. It was implicit in all of the discussion so far, and that has to do with how many names you've got, right? So if we talk about the Bitcoin address space, it's large, but it's finite. It's practically infinite, but it's not infinite, okay? But we could imagine that there are namespaces that are infinite and that we can describe them with tiny programs. So here's a tiny program, add 1. So if I start with 0 and I add 1, then I get 1. Right. Now I have 0 and 1. If I add 1 to that, well, I have 1, 0, 1, and 2. Add 1, 0, 1, 2, 3. So all of the natural numbers can be thought of as a namespace that has a compression. What's the compression? I can shrink the whole thing down to 0 and the rule add 1. Does that make sense? Right? So I can take infinite namespaces, right? And I can shrink them down to rules. And this is one of the most powerful ideas of the namespace idea, that we can describe URIs, for example. URLs and URIs, they're infinite. There's a rule for, because you can have the path go on as long as you want, right? There's no bound on the path of a URI. But there's a set of rules for what forms a legal URI or a legal URL, right? And that turns out to be of significant power because the rules for building up namespaces, these infinite sets, are how we glue namespaces together. The rules, track this, the rules for how we compress namespaces are also how we glue namespaces together. That's essentially the heart of the row calculus. And the same thing is true when we talk about the agents that utilize those rules. The rules for how we can compress or describe the behavior of an agent is also how we glue agents together. All right, so that's a strange idea, but it turns out to be incredibly powerful when I can just quickly show you how tiny that rule set is. There. That's how big the rule set is. It fits on a page. And that's the way it's supposed to be. Because when you have the rules fitting on a page, you have a chance to reason about it. And when we talked a bit before about being able to make this thing robust, one of the things that makes it robust is that it's codified in this tiny form that allows us to reason about it in an automated fashion, right? So again, I had kind of hoped there would be more repeat customers, so I didn't have to go over a lot of the same material from the last time. But so let me just leave it there and see if you have any questions. Any questions concerning this?
So the matrix you had showed earlier,
if you want to have a model of computation that serves the blockchain, right? We just went through this. If you're going to achieve 40,000 transactions per second, you can't do this with a sequential computer. Your model of computation cannot be one step at a time. You have to have multiple threads all running together, possibly synchronizing, but most of the time not synchronizing, right? That's a hard performance requirement, right? So that basically eliminates all the proposed models of computation and puts us squarely only in those models that have concurrency. And there are a handful of those, of which the pi calculus is one of the best, and the row calculus is better for this particular domain of application. So it's just concurrency, right? We also want basic engineering. You write a contract. Ed writes a contract. David writes a contract. I want to be able to write a contract that glues those together. Right, that's how we do engineering, right? I make a thing that solves a problem. You make a thing that solves a problem. I make a bigger thing that solves both problems together and package that up as a solution. That's called compositionality, right? So that eliminates a lot of models of computation. I can't use Turing machines because they are not compositional. I can't use Petrinets because they're not compositional. So we got rid of a bunch of models of computation just by looking at those two requirements. Complexity, okay? So one of the most popular models of computation is the lambda calculus. Lambda calculus sits under what? It sits under OCaml, Clojure, Haskell, Scala, etc. Now, is that a good model for the blockchain? No. Why? Well, because the lambda calculus does not have a good model of complexity. That's why until Jean-Yves Girard's linear logic came along, you didn't see papers about the complexity of lambda calculus because it doesn't measure that. Beta reduction copies resources everywhere. Okay? Does that make sense? It also turns out that Berry's theorem tells us that the lambda calculus is sequential. So it's also eliminated from that point of view. So if you just go through each one of these, each one of the requirements for the blockchain, you just nope, until you're left with 3 or 4 of these models, and only one of them has all of the characteristics. And so that matrix is describing the kind of computational agents that are good for the blockchain. And then because of this other idea that the computational agents are recursively related to the namespaces, right? Names and agents, just like, space, time, and the distribution of matter and energy, right? Those two things are recursively related, right? And so that basically only selects the row calculus as the model that fits this space, fits this domain. Any other questions? Yes.
So these are the simplest operational semantics you can put on this kind of stuff.
Yeah, that's right.
Right? So, but it sounds like you're saying, but not quite saying, and I think this answers a question that I had, which was, I'll start with a question. Is there a reason that the VM has the semantics built in particular the row calculus semantics built in? Because the VM doesn't have to. You can just be executing things that make these same effects these do, but it sounds an awful lot like you then want to take interacting contracts and reduce via reductions or whatever structural things you have at hand and simplify the operation in that way before you even execute the thing.
Yes, and the answer is correct by construction. So I eliminate proof burdens on the correctness of my programs if I know that my programs derive directly from this model. If I have to go through a compilation step, then I have to, on the one hand, have an independent semantics of the model that's actually executing, and then I have to prove that the compilation process is correct, that the execution semantics is respected through the compilation. And then on top of that, I have efficiency concerns. So yes. Any other questions?
I have a dumb question. Is there any, I mean, if this is a superior VM, is there a possibility that like the row VM could just get dropped into like Ethereum?
So the Ethereum, you could go the other way. You can't go the direction you're talking about. It won't work because Ethereum fundamentally depends upon sequential execution. You would break all kinds of guarantees about how contracts execute if you tried to do it. Drop the. So that's kind of the short answer, the pithy answer. Now.
Why Ethereum would never be fast enough.
So that's kind of the short, narrow technical answer. Okay. Now it turns out you can go the other way. You could write a compiler from the Ethereum VM onto the Rho VM. Now you would suffer because you'll still have all of the slowness of the sequential execution model. Right. So there's no good point for it. On the other hand, now you never heard me say this. I know that I'm talking to the camera. but here's the reality. I was 2 months ago sitting in a room with all of the major financial players, right? So you can imagine who they are. I'm not going to say their names. And what they were talking about in terms of Ethereum was, well, we want to abstract away the VM, and we want to abstract away the consensus algorithm, and we want to abstract away the storage, and we want to abstract away the COM. So what's left? well, the exchange rate and the name, the brand. Okay, so I'm just telling you the facts.
I was just wondering if it was like a community will thing, like, we'll just break every single existing smart contract and then make that switch if that was needed for the next phase of that.
Well, I think the way this is going to play out is that as the gains in performance and correctness begin to demonstrate themselves, once already we're seeing in our storage layer. This is just the storage layer. I'm not including the network overhead or the VM overhead. At the storage layer, we're already seeing 80,000 transactions per second without breaking a sweat. Okay, when we add the network layer and the EVM overhead, that'll halve. So we'll see about 40,000 transactions per second. Okay, that's still well within our target because we basically just have to be better than Visa at this point. And then we actually have to start pulling out our hard engineering, chops and then really optimizing and then get to around, 100,000 transactions per second, which is what will need to be Visa plus Facebook. Okay, so as this starts rolling out and we start to see these kinds of performance gains, and we also see that, hey, when you program like this, the compiler catches your bugs, it catches your race conditions and your reentrancy problems and all of that, right? And it's just built into the way you develop code. Then again, that kind of robustness gain as a part of the methodology is just going to speak for itself. And so what you'll see is people going, I love Solidity. Oh wow, this RChain thing is pretty sexy. Oh, let me try a few examples. Oh wow, this is really cooking. This is much fast. Hey, I can write social network applications using this thing. I can make each post be a smart contract, right? That's kind of the path that I see here. Does that make sense?
Sorry to keep harping on this, but what if it was implemented as like a secondary layer on top of Ethereum?
Okay, so it's a good question. It's an interesting question. So again, remember the Ethereum virtual machine is sequential. So what you're going to do is you're going to take all of this great concurrency and compile it down to a global schedule, losing all of your performance benefits. Does that make sense?
Let me ask the question, because we get this question a lot, and I'm trying to understand what's motivating the question. People are trying to, I think, save the hard work they've done on Ethereum from, the user experience, the concept, and the smart contract. I think that general motivation is great, and the user experience doesn't have to change at all. The business problem that you're solving doesn't have to problem at all. Your customer base can migrate, but the smart contract will have to change. But it's worth it same business concept. If it was good in Ethereum, it'll be better on RChain.
Yeah.
Just my basic motivation,
Yeah.
like I think is the number one for cryptocurrency is like, or my number one thought process is, am I gonna get screwed? Like just paranoia, like don't get F'd here, left and right. So like if Ethereum is truly like obsoleted, then that's kind of an issue.
Oh, I see. Okay, so your question was as much about concern for investment in Ethereum, investment in your time, energy, and so forth. Well, I think it's an excellent platform now, and you can certainly work out all of your concepts and so forth. But I hope RChain will eclipse Ethereum in a year
Yeah.
or a year and a half.
Yeah.
So but I think that building businesses on Ethereum today is not a bad idea.
I mean, think about it like, developing. Here's what happens in the financial industry all the time. A financial analyst, propeller head PhD, either in physics or economics or both, comes up with a really brilliant way of thinking about the market, right? And then they pair up with someone who rapidly develops those ideas in the language R. And R just isn't going to scale for, high volume trading, right? So then they take another year, having rapidly developed like that, and put it into something that's scalable. So that kind of waterfall development methodology could easily work here. So you can go work out your ideas in Ethereum at the 20,000 foot level. Now, and then when you go to RChain, it'll just work better. The one thing you won't get is learning to think concurrently. Okay? So if you bite that bullet now and you learn how the concepts inside RChain and how they fit together, because what I've discovered is it takes a trick of mind, right? Usually we need either young developers or people who have a lot of networking experience. Either people whose minds are still very flexible, or they know what it's like to live in a concurrent world, right? So that's the caveat to what Ed was talking about. Makara.
Yeah, well, this is a non-technical question. But
Please.
I would like for you to speak for a few minutes about what will the world be like? What will change in the world? How will it be different? How will it affect me who's not involved in technology?
No, I think that's a great question. I think Ed tried to set that up, but let's go through this again in a more detailed.
After your presentation, I think it would be
Yeah.
to revisit.
Yeah, sure. No, I think it's a really important one. Let's consider just the experience on social networks. Like a lot of people here use Facebook. Now, let's think about how Facebook uses you. Okay, so Facebook takes a lot of your personal data. You have very little privacy when it comes to Facebook, and Facebook sells that data on to advertisement firms and other kinds of governmental entities and non-governmental entities. Additionally, if you compare Facebook to 50 years ago, the equivalent of Facebook was the New York Times. Right, so let's think about New York Times and how content was created and managed in the New York Times. It was created by writers and editors that the New York Times paid. So in this room, whoever's a Facebook, user, you're a writer. And if you're curating content of your friends, you're an editor, right? Do you get paid for that? No, you don't. And in fact, if we look at the trends of the creative class against the distribution models that are currently being foisted upon us, for lack of a better word, the creative class is pretty much under threat. Yes, they potentially have a reach, but their ability to participate in the economic boon of that new reach is dramatically reduced. Dramatically reduced to the point where just a couple of years ago, David Torn, world-class guitarist, right? He's respected by musicians and people the world around. He posted that Spotify paid him $8 for a song that had hundreds of thousands of plays or millions of plays. Now, if that trend continues, we don't get world-class musicians. We don't get world-class reporters. We don't get world-class graphics artists. They evaporate, right? Because they're too squeezed by the distribution model, right? So if Facebook were at least to help people participate in the economic engine, right? That would be one thing. But it's worse, right? It's worse because at any time, because Facebook's corporate offices are in the US, at any time, the NSA can walk up to Facebook corporate offices and say, hey, here's a court order from a secret court. Give us Mukara Meredith's data, please. And if Facebook wants to keep doing business in the US, they go, yep, here you go, right? And it's worse than that, because Facebook is not just susceptible to these external pressures. Internally, they have pressures. Facebook has already published reports in psychology journals showing their experiments that they have run on users, manipulating their feeds, right? So how that changes? In the new model, you can have a social network where no one is in charge. There's literally no Facebook corporate offices. It works in a decentralized fashion. The community curates the content. The community is the economic engine that makes it sustainable. So that's just one example, right? So it's not just Facebook or Twitter or Instagram or Snapchat or all of those things change. Map services, right? Who in this room navigated here using Google Maps? Right? But because of those map services, guess what? Google knows exactly where you are when you are there, right? And so again, the NSA can walk up to Google corporate offices. Here's a court order from a secret court. Please tell us where Mukara Meredith is. All right? Go ahead.
Problems in your system, they don't necessarily go away. You're still going to have insane people in the world doing insane things. But what I'm trying to understand is there like less sacrifice? Because like as a DJ now, it's like, yeah, I don't make money. My living's not in DJing, but I still want to DJ. I have to sacrifice, so I can't make a living doing that. So I have to do other things. That's just on the job front, but in the community front, when we're dealing with somebody who's posting really just morally incorrect content.
Right, okay.
So
Yep.
there's still
Yep.
sacrifices we have to make.
Yes.
So we have NSA to protect us. So when we have decentralized, the whole sphere of justice is changing, correct?
That's correct. You nailed it, right? So the issue is when you move to the decentralized model for these kinds of services, then you also have a new governance equation, right? And one of the things that I have noticed, it's not always the case, right? We've seen lots of situations where it isn't the case. But one of the things that I've noticed is when we get together with goodwill, there's a higher quality of attention. And it's the quality of attention, right, and the goodwill of knowing that we are participating in a community that makes it possible to notice that kind of thing, and then as a community say, no, that isn't for us. Find another community. Go ahead.
So the greatest threats to humanity right now, nuclear weapons, probably military-industrial complex, right? Weaponized technology.
Yeah.
So in your model, because the transparency would help us like catch that behavior and maybe disarm it.
Okay, there are. That's a deep question.
It is.
Let me take one step back. Okay, so the financial crisis of 2008. One of the things that had me building the precursor to the RChain network was I looked at the financial crisis of 2008, and because I work in technology, I was connected to I was connected to people like the CTO of Goldman Sachs and the those kinds of people, and so they told me a year in advance, shit's coming down the pipe, right? Get out of these, right? Get out of real estate, move your money, because they knew a year in advance what was going to happen. But there were like 5,000 people on the planet who knew what was happening. And I said to myself, hey, if I democratized all of the financial models so that if I had not 5,000 eyes on the models, on the analytics, but 5 million eyes on the models, right? This is about when we get together with goodwill. So if you had 5 million eyes on the financial models, then what would happen? One of those people is likely to go, hey, the emperor has no clothes, right? When you have 5,000 eyes, it's a closed club, and they're just going to make, make as much money as they can out of a lot of people suffering. But when there's 5 million eyes on it, at least one person is going to go, there's a problem here. And then another person is going to go, there's a problem here. And in fact, this actually happened, right? So Patrick Byrne, the CEO of Overstock.com, he started to see this in 2005 and 2006, and he started to go to the SEC, and he started to go to New York Stock Exchange, and he started to say, I think there's something fishy here. I think there's a problem. And this 5,000 member club said to Patrick Byrne, you used to be the darling of Wall Street, but you better cease and desist now. You stop rattling the chain or your life is going to get miserable. And he reports this in Wired, right? He was subject to federal lawsuit after federal lawsuit, each of which was baseless. Because he had the financial wherewithal, he could defend against that because he kept all his books super clean. He could defend against that. His conclusion was that just the financial part of this network is too corrupt to fix. And the only chance we have is to build something on the side and then jump ship. Right? Does that answer your question? I mean, I'm not talk to Vlad. He has thought really deeply about the ethics of blockchain, right? I can't address nuclear agency, but
I was just going to agree and amplify, but with a spin, and that's to say, I grew up in the South. Greg and I do not have very similar values. We don't think very similarly about a lot of issues. But one of the things that we agree on is that this kind of world creates the ability for people to form their own communities, and govern them the way that they want, right? And so no matter what your values are, that's going to help you out, right? That's going to keep you from getting under somebody's boot, or it's going to keep you from ending up in a spot where you don't want to be because you don't like the rules and you prefer to move on. And that, I think, more than anything, that's going to be one of the biggest changes for people is that they don't have to participate in stuff they don't want to.
Evan.
So how do you reconcile this sort of challenge that I think decentralization is having of expertise and democratization are sort of in tension with one another? If you democratize something, for example, reporting, where you've got 500 million people doing reporting, the quality and professionalism of it tends to decrease. Yeah. But if you have expertise, or you have a small number of very professional types doing a certain task, then you kind of have to trust them. And if one of or a small number of those actors does something amiss, that's harmful.
Yeah, no. So I love this question, and I think it points to something that I haven't been talking about for the last year because I've been so mired down in all the details. First of all, this is just the base layer of the platform that I'm aiming for. There's a whole set of social technologies that live above this. I can talk about it in terms of examples that are directly related to this technology and then climb up the ladder, and I'll do this as briefly as possible. So first of all, when we talk about the formal methods that are being utilized to prove the system correct, but also being baked into the methodology of developing the contracts, one of the things that formal methods does is it reduces your need to trust the dev team. Okay, so let's think about this. Is Bitcoin actually a reduction in trust? I think the bubble in the carpet got moved over here from the banks to the Bitcoin core dev, right? You got to trust them. Either they got the code right or they didn't. But we have no way of knowing whether they got the code right because there's no independent specification that this is in fact correct, right? Bitcoin is its own spec, right? Bitcoin core dev is its own thing. And so you can only measure it against itself. If you have an independent semantic specification and you have automated verification, then at least you've expanded. I mean, you still have a room full of propeller heads, but you can have lots of rooms full of propeller heads. I mean, probably Mukara, my mother, is not going to go verify the correctness of the row VM, but it can be verified by independent parties. And it can be done, so the amount of trust is reduced, not eliminated, but it's significantly reduced. So that's step number one. But beyond that, one of the things that we've found is that the gamification of certain kinds of processes is a part of this kind of ratcheting up of attention. Okay, so let me try to make this as concrete as possible. Back in 2009, I ran an experiment with Luke Homan. We were applying his idea of buy a feature, which is a market-like game for people like Augur, for people to think about to think about the features of a particular system, right? So if you're designing the iPhone, all the stakeholders in Apple might get together and they might throw the features into a bucket and shirt size those features, small, medium, and large. Then they might all get together and be handed out play money. And then they horse trade over the features they want. And that kind of process of, no, I think it needs to be bigger. No, I think it needs to be slimmer. No, I think the UI needs to have more buttons, that kind of thing. No, we have to have a better response to the to customer complaints, that kind of thing. So all of the feature sets, the negotiation around that in that kind of setting turns out through decades of Luke's investigation to give you better understanding of the collective understanding, the collective intelligence around the feature set, if you play these kinds of games. So we thought, hey, why not apply this to social issues? So we in Seattle, we ran buy a feature games around healthcare reform. So we shirt-sized the features on the Senate and House healthcare reform proposals, and we gave people monopoly money, and we let them play it out. One of the first things that happened, because we couldn't give them the detailed proposals, which were this thick, right? We had to shrink it down to a list of features that they could understand, right? And the first thing that happened was, I don't understand this feature. What does this feature mean? So the gamification begins to increase education. People start pulling for information as a part of participating in the game, right? And they pull for information to the level that they can. This is leveling up in a game, right? Or leveling out in a game. I want to get this far into the game, and that's as much as I can handle, right? And through these kinds of processes of gamification of these sort of social issues, people have shown that their level of their feeling about being participants changes qualitatively, but the collective intelligence is activated. So Luke has gone on from those exercises to run San Jose budget games. And people come away from those in tears of gratitude, tears of joy. I have never felt so heard in my life as when I have played these games where the city council lists out, here's the things we want to spend money on, you tell us. And they go through this negotiation process, they go through this gamification process, and then they walk away with a picture of what the group has said is important for the allocation of funds for the city of San Jose, right? So this is the kind of thing where I believe that the gaming and the activation of collective intelligence through games is what mediates this tension between expert and novice. Does that make sense? Long-winded answer, but does that make sense? It's getting really late. I feel like I should let you all go. I really appreciate your attention and your engagement, and you know. Well, if you want to go, that's fine. No, go ahead. Okay, so the question is, what changes the subject a little bit? I don't know anything about patents other than a simple understanding of patents. They're very simplistic notion of patents. But one thing when I look at open source is I think, well, I don't know this. My assumption is people don't really go after folks that have put technology out as open source, meaning lawyers and such. You're not getting sued. You just write code, stick it out there. It's open source, and you're generally safe. If I'm wrong, correct me, but that's my general impression. Okay. Now, it seems to me that when you put money at these things, right, you issue your own token, right? Now there's value there that people can go after. So you were talking about the artist that got $8 for 100,000 plays. Well, if he had open sourced that song, I could have, or a song, right, you know, that he got $8 for. In a new system, if he got paid a lot more, but he open sourced it, I could just take that song, change one bit, and create a new contract that pays me. And so it seems to me that when we start to add money to these, there's something to figure out there. I absolutely agree. And look, RChain doesn't solve every problem. We believe that there are very tough problems with respect to provenance that hopefully RChain Holdings will be able to solve.
The spam team at Google runs but anyway, the spam team at Google runs a humongous amount of infrastructure to figure out things like this video is copied back to you.
Yes.
And by comparison to the actual search for videos function in YouTube, right, the spam stuff is way bigger, right? Now the streaming or whatever is the bulk of it, but the spam work is really large. So
Yeah.
you're not just going to get it for free in blockchain.
No.
There's actually semantic analysis of actual human content.
There are several blockchain companies that are addressing provenance. One of them that I really have I have my eye on is Ascribe. They're based in Berlin. They're quite good. So if you're interested particularly in the provenance problem, or then look at Ascribe. Yeah. Trent McConaughey, I think is. Yeah.
There's one other concept. Sorry,
No, go ahead.
So have you heard of open business? This concept that seems to me that when you have all these contracts, you can actually kind of turn business inside out, where how the business runs, its business model, and all of that is not held a secret, and that it's actually open.
Yes.
And how you participate in that are governed by the business model as coded in these contracts. So is that in line with your thinking?
It's not just in line with our thinking, it's in line with our practice. Effectively, we conduct our business on YouTube, right? I mean, by and large, most of the team coordination happens, in the public eye.
So there's transparency, but there's also, you could just say, even like 10 people are going to go in a room, that's not going to be transparent as what we talked about, but what comes out, that is the process. We're open about the fact that 10 people go in a room and they talk privately. And then out of it, we're going to have a bulleted list of the items that we chose. That's the transparency, but then the openness is that was the process.
Yeah.
So you may not disclose what everybody makes, you might not disclose all these things, but
Yeah.
the internals of the definition of this enterprise are its practices, its policies, its procedures, its workflows.
We take it a step further. Our belief and my personal experience is that when you do that, that's your marketing. That becomes one of the key marketing features. People can go and see, oh, look, they're actually doing this, this, and this. Every day they're talking about these issues, and those are the issues on the line items that we paid money for, right? So people, you begin to build credibility. People start getting engaged. They start going, wait, what if you reordered this? You'd save money here, right? And now the community is you know, they're stepping up to the plate. So yeah, I believe that that's definitely the way to go. Yeah, for sure. We gotta close out.
So